Welcome back to the lecture series on data structures. In this lecture, we talk about heap sort. In the previous lecture, we talked about operations on heap, insertion and deletion of elements into the heap. Now, the idea is the max heap, in case of max heap, the maximum element will be present at the root, and continuously that max element will be swapped with the last element. And after swapping, if the heap condition is lost, we need to readjust the nodes or the elements in such a way that the heap condition is satisfied. That is called heapified down, in the sense since it is swapped with the root node has to be brought down to its corresponding location. This has to be done repeatedly, one after the other, until all the elements are sorted. In this example, we'll consider 90 is the max element present at the root, and we swap with 28. After swapping, 28 is at the root and 28 is not the max. So obviously we need to check with the children. 80 is child of 28, so obviously we have to swap them, swap 20 and 28 and 80. And after swapping, 80 is the root node, 28 and 70 are the children of 80, so they are satisfied. But after 28, 62 and 57 are the children of 28. Again, we need to swap 28 and 62. So for 62, 28 and 57 are the children, and for 70, 57 and 42 are the children. So at this point of time, heap condition is satisfied. And again, in the second round, we need to swap 80 and the 42. We ignore the last element 90, which is already sorted phase. So we swap 80 and 42. Again, 42 reaches the root node. 62 and 70 are the children of 42. We need to swap with 62 first, and 62 again is less than 70, so we need to swap 70 with 62. So now 70 are the root node, 42 and 62 are the children of 70, and for 42, 28 and 57 are the children. Again we need to swap 42 and 57. After swapping 57, it is in the heap condition, is satisfied. Now again, the top element 70 is to be swapped with the last element 42. So after swapping, again 42 comes to the root, and again we need to heapify down. For 42, 57 and 62 are the children. Obviously we need to swap 57 with 42, and again we need to swap 57 with 62. So after swapping, 62 is the root node, 42 and 57 are the children of 62. Heap condition is satisfied. 42 is the parent of 28, so heap condition is satisfied. Now again, the third round is 62 is to be swapped with 28, so that 28 reaches the root node position, and 28 is root node, and 42 and 57 are children. Again we need to swap 42 with 28 and 57 with 42. After swapping, 57 becomes the root node, 28 and 42 becomes the children. So heap condition is again satisfied. Again, we need to swap with the root node with the last element. 57 is swapped with 42. So 42 is a root node, 28 is a child. So heap condition is satisfied. Again, we need to swap the root node with the last node, 42 and 28. After swapping, 28 comes first, 42 goes next. At this point of time, the entire array is in the sorted order. This is how it works. When it comes to the algorithm part, we'll take heap and max index as the inputs. Max index indicates the last element of the heap, and if heap is equal to null, return heap, nothing to be sorted. Else, while max index is greater than 0, we need to repeat using a while condition until max index is greater than 0. Swap the first element with the last element, that is heap of 0 with heap of max index minus 1. Just recall that max index starts from 1 to n, it runs from 1 to n, whereas array index starts from 0 to n minus 1. That is why we are taking heap of 0 with heap of max index minus 1. Swap them and update the max index as max index minus 1. Why? Because after swapping, we are not considering for the remaining part of the sorting, because that part is already sorted. Max index is equal to max index minus 1, and then the remaining part, whatever is there, it has to be heapified. So heap is equal to heapify of heap. So we need to heapify down. This has to be repeated continuously until max index is greater than 0. At the end, we should end up with a sorted array. Now, when it comes to the heapify part, how do we do that is, for I running from 1 to floor of max index by 2 in steps of 1. That means every time whatever max index is there, max index by 2 gives you the parent. So until we check the last parent node, whether that parent node is greater than its children or not. So how do we check that? If heap of 2 times of I is greater than heap of I and 2i is less than max index, that should not exceed the existing index. Then if the child is greater than that, swap with the parent. So swap heap of I comma heap of 2i, or that is the left child, or the right child may be greater than that. So else if heap of 2i plus 1 is greater than heap of I and 2i plus 1 is less than or equal to max heap, then swap the right child with the parent. So either if left child is greater than parent or if right child is greater than parent, we'll swap this. We'll do this in the for loop starting from the root node until the last parent. So this is how we run the algorithm, and we can sort the array.